students, welcome to physics class. Today we will discuss about relation between R and F. Here R is called as the radius of curvature. It is defined as the distance between center of curvature and pole. The distance between center of curvature and pole. And F is called as focal length. It is the distance between focus and pole. The distance between focus and pole is called as focal length. We have to derive the relationship between radius of curvature and focal length. For that, let us consider a concave mirror Mn. Let us consider a concave mirror Mn. Here AM is the incident ray. Incident ray and MC is the normal. MC is the normal. Whenever we have drawn a normal to a curved surface, it will pass through its center. Here center is called center of curvature of the mirror. Always we will take the angle of incidence or angle of refraction with the normal, that is the angle made by the incident ray and normal is called as angle of incidence. Here the angle of incidence is theta. Theta is called as angle of incidence. Angle of incidence. Angle of incidence. Angle of incidence, that is the angle at which the incident ray AM is incident on the mirror. And we know that from the laws of reflection, angle of incidence must be equal to angle of refraction. So the incident angle is theta and the reflected angle is also theta. So the angle made by the incident ray with the normal is angle of incidence, and angle made by the reflected ray, here FM is the reflected ray. Reflected ray. So angle made by the reflected ray with the normal is angle of reflection. Angle of incidence must be equal to angle of reflection. So here the angle must be theta. Now whenever a parallel beam of ray incident on a concave mirror, then after reflection from the mirror it will pass through the focus. After reflection from the mirror it will pass through the focus. So the reflected ray is passing through the focus, and we have to know here that whenever there exists a parallel rays and another ray which is cutting these two parallel rays, then the interior angles must be equal. The interior angles must be equal. Interior opposite angles must be equal. So here the angle is theta, then here the angle must be theta. So here AM and XY are the two parallel rays, and MC is a line cutting these two parallel lines. Then the angles in the interiors must be equal. Opposite angles in the interior must be equal. In the same way, there exists another ray which is cutting these two parallel rays, which is passing through F. Then from the figure it is clear that here the angle is theta, so the total angle is 2 theta. The interior opposite angles must be equal. From this principle, from this condition, we can say that the angle at point F is 2 theta, which is equal to the sum of theta plus theta, the interior opposite angles must be equal here. And we know that the distance between capital F and P is focal length, and the distance between C and P, center of curvature and pole, is called as radius of curvature. Now we will take the triangle from the triangle CM, let us say P. In the figure, the CMP is not a triangle. Here CMP looks like an arc. So in order to form a triangle, we will draw a perpendicular line, foot of the perpendicular. The point foot of the perpendicular here is D. For the mirror which is having lower radius of curvature, the distance between D and P must be very small, so we can say that D is approximately equal to P. For the mirrors which have higher curvature, then the distance between D, the foot of the perpendicular, and P is greater. The distance between D and P is greater, so we cannot say D is approximately equal to P. Here we have taken a concave mirror of less curvature, so we can say that D is approximately equal to P. D is approximately equal to P. So in order to say the triangle CMP, we can clearly say that the triangle CMD. From the triangle CMD, we can write tan theta. Here the angle made at point C is theta, so tan theta is equal to opposite side by adjacent side. The opposite side is MD divided by the adjacent side is CP. We can say that CD. We know that D is approximately equal to P, so we can write MD divided by CP. Instead of CD, we can write CP. MD divided by CP, the value of CP is radius of curvature. So capital R, tan theta is equal to capital R. In the same way, from the triangle FMD, tan 2 theta. Here the angle at F is 2 theta, so we can write tan 2 theta is equal to opposite side divided by adjacent side. Here opposite side is MD and adjacent side is FD. Here D is approximately equal to P because we have taken a mirror of lesser curvature. Yes, therefore tan 2 theta is equal to MD divided by FP. The distance between F and P is nothing but the focal length, so we can write MD divided by F. We have derived two expressions. First one is tan theta is equal to MD by R, and tan 2 theta is equal to MD divided by f. If theta is very less, as theta is very less, then we can write tan 2 theta is approximately equal to 2 theta, and tan theta which is approximately equal to theta. Here theta is angle of incidence. For lesser angle of incidence, for minimum angle of incidence, tan 2 theta must be approximately equal to 2 theta, and tan theta is approximately equal to theta. So we can write that 2 theta is equal to 2 into theta. 2 theta means tan 2 theta. We have already derived tan 2 theta is equal to md divided by r, and tan theta which is equal to md divided by f. Here 2 theta is approximately equal to tan 2 theta, and theta is approximately equal to tan theta. So we can replace tan 2 theta as md by r. So md divided by r, which is equal to tan theta is replaced by md by f. So 2 into md divided by f. Here md gets cancelled. So 1 by r is equal to 2 by f, or we can say r is equal to f by 2, or we can say f is equal to here we have made a small mistake. We know that tan 2 theta is equal to md by f, and tan theta is equal to md by r. Here md by f and md by r. We have already derived, but we have taken as tan 2 theta is equal to md by r, which is wrong one. We have to take md by f. We have already derived that. Here md by r, which is equal to tan theta. So we will substitute the values here, and we will get the correct expression. Please note down this. md divided by tan 2 theta is equal to md divided by f, and 2 into theta is md by r. We have already derived these expressions and noted in a wrong way. So by substituting the correct values, we get 1 by f is equal to 2 by r. Therefore by cross multiplication we get r is equal to 2f. This is the correct expression for the relation between r, radius of curvature, and f, the focal length. Thank you.